Good morning, everyone, and thank you for attending today's Lunch and Learn session, Complete Traceability. How well are you tracking your people and products? My name is David Schaefer. I'm a Senior Account Executive here at CAI Software. Throughout today's session, we welcome any and all questions. Please use the chat function at the bottom of the webinar window at any point during the presentation to ask your questions. We'll field any and all questions at the end of the presentation. We'll also unmute the audience to ask questions audibly. So today's featured presenter is Matt Radford, Director of Professional Services with our ShopView MES product team. Matt brings more than 17 years of experience in the manufacturing sector, spanning the automotive and aerospace industries to tooling and information technology. His passion is finding innovative solutions to complex challenges and empowering manufacturing teams to achieve excellence. Matt graduated from the University of Windsor with a BA in sociology and holds a number of licenses and certifications, including an Agile Scrum Master and various other strategic and operational certifications. Matt has led and managed over 100 enterprise-wide projects, both large and small, in scope for various MES and ERP projects across multiple facilities and regions, delivering operational efficiencies, cost savings, and enhanced business visibility. He brings a wealth of real-world and pragmatic recommendations to companies of all sizes. And with that, I will hand it off to Matt. Matt, take it away.
Okay, thanks, David. I'm just having some trouble with my camera, so while I'm presenting, I'm going to stop my video. All right. So welcome, everybody, to the second installment of our aerospace series. We're going to be focused on traceability within aerospace, what some of the challenges are. I'll do a brief little overview here, what some of the best practices are, and most importantly, how modern systems can help support some of the complicated and complex requirements of various facets of the aerospace industry. So why is aerospace different? It's really not to a large degree. The requirements are the same. Most people want to track their product. They want to know what went into what. What I find in aerospace is that it's far more detailed. The products are more complicated, usually with a deeper bill of materials. And the requirements are strict and enforced from multiple bodies around that are listed at the bottom there that kind of push those requirements down onto suppliers. So it's taken very, very seriously. The way that I'm defining it for this discussion is really the ability to track the history, location, and status of any of your items throughout the whole life cycle, including employee and machine activity within the process. So what I mean by the life cycle is sometimes you'll ship a part, but oftentimes if it's an assembly or a fuselage or any kind of element of a plane that might come back to you, you might be doing repairs on it in the future. We want to capture all of that and truly understand everything that's happened from cradle to grave for each piece. So the key elements, being able to identify components, finished goods, WIP, any element within the build of a part as an individual is super important. Most aerospace companies will have a mix of serial and lot tracking, lot being a group of parts, serials being an individual. There's also, depending on your commodity, things like batch numbers, heat numbers, if you're heat treating, could be melt numbers, if you're a casting or a forging house and you're melting your metal. I've seen a number of unique and various types of tracking mechanisms. So this kind of differs by part of the industry that you work in, but there's a bunch. So being able to pull that information and track it is the key. All documents, records, and that includes within the process, what the people are doing, how are they working through their work instructions? What type of data are we recording that's not on paper, but going into a system and linking it to that unique item that you're tracking? And then ultimately, if we're doing all of that, getting to like a traceability report, and this can come in multiple forms. I prefer like a visual, diagram with boxes and lines and drill-in capability showing like what went into what was connected to what, how the whole, life of that part occurred, all in one place is sort of the crown jewel of getting your digital systems to work together to provide that traceability. And again, like we talked about in the last session, lots of requirements in aerospace that are driving these mandates and requirements down the supply chain. So some high-level examples of where traceability is needed in aerospace. So there's both internal and external approvals. Sometimes to ship parts, you have customer approvals that need to happen ahead of time. You send them information, they approve. You also have internal gates like quality inspectors and inspection operations where people may stamp parts or approve the parts to proceed because they've validated that things are done. Those are all things that are done in modern systems off the paper. The ink-based stamps are gone and people are stamping digitally. Adherence to protocols, and protocols is sort of a catch-all for processes, inspection plans, work instructions, all of the things that guide the operators and the people making these parts to completion and tracking all of that. So for instance, if you have a tolerance on a wall thickness and you're doing machining and you're outside of that tolerance, you're going to want to be able to report that that occurred, but also stop the process or poke yoke the process to not let it proceed and without the proper approvals, which can all be held inside the system and then reported on for traceability. Audits, because all of those bodies that I spoke about the last time and were listed on the first slide there, NADCAP and AS 9100, heavy on the audits, both internal and then their audits. Lots of corrective actions and processes come out as a result. So digitizing that and adding that kind of information in and cross-referencing it with your manufacturing traceability and data is very powerful in reducing overhead for those certifications and improving your processes. Quality assurance. So process monitoring to me is, again, both people and machines. We want to connect to machines and we want to understand, the parameters and the process that's occurring and stop and alert if it falls outside the parameters. But we also want to monitor how the people are carrying out their process. Are they doing their inspections? Are the results as we would, think that they should be? Are they within the realm of acceptability? Do they need to ask for help? Can they do that? Can we record that that's happening and who's making decisions? All of those things kind of create this process that as you go and have issues in the future and you want to look backwards, are very helpful to know to add context to what actually occurred. And then, sort of the backward-looking view of traceability is the negative one that people go to. Well, what if we have an issue with the customer and I have to go back and say exactly what happened and what's affected, which is absolutely true and a great reason to implement traceability. But when you digitize it and you start getting a lot of this process information and quality information inside of your systems, you can use it for forward-looking things because it's no longer just a sheet of paper that goes in a filing cabinet. It's something you can put a dashboard on, trend, put into a data lake or an analytics engine, and all of a sudden you have access to this information that existed but was in a filing cabinet or a banker's box somewhere, not being trended or really reviewed. So you can improve reliability of your products and your process by leveraging that information going forward. Supply chain management and risk mitigation, deeper the supply chain, the deeper the bill of materials. People that do big assemblies in aerospace have a large amount of outsourced parts and processes that occur. So being able to integrate, track where your supplier's parts are at, if there are issues, what did they do? How did they disposition it? Did you accept it? What do your incoming inspections look like? All of these things now are within these systems to help make it easier for suppliers. So again, even automating supplier audits and inspections that can be sent through a portal or through email, and they can then proceed and you can track that information. Lifecycle management and maintenance, what I'm referring to there is more MRO activity or repair and overhaul. So I'll use like a jet engine as an example. If you're producing or assembling a jet engine and it goes out into the field. I know that's a big example, but just for context, it's going to come back. You're going to do maintenance on it. You're going to have to repair things. So knowing what you're replacing, if it's a serialized component, what did you replace it with? How often are you replacing it? You can really start to predict what you need to stock, predict the processes that are going to occur as these things come in because you're seeing the repeat failures. You can even drive that back to how you're producing it to improve your manufacturing the first time and do less of that in the future. So getting all of that life cycle and after shipping maintenance collected, I think is a big deal to trace as well as improve. Challenges in the aerospace industry when it comes to traceability. Complexity, like I talked about. I mean, a plane has 1,000,000+ parts from thousands of suppliers. Traceability systems can track all of that if it's set up right, if the discipline is there in your operations to be tracking it and recording it. But it does present a challenge, especially if you're working with multiple materials. So if you have composites, if you have different alloys or different metals, whatever materials you're working with come with their own unique set of traceability requirements, testing requirements, inspection requirements, and skills required to do the job. So that does make it a little more complicated to trace and to improve. Rework and unplanned operations, in my experience in aerospace, was always a big one. I've worked in some places that are making highly complex metal parts from castings up that have very long lead times, a lot of repair and rework, cycles of repair and rework. So there's commodities within aerospace where rework, is a major part of the part's life. And sometimes tracking all of those activities, making sure that the operations are accounted for, that the ME is bought off on it, that the inspectors are buying off on the right things, and tracking those unique inspection opportunities to trace on are very important and also a challenge. And again, even swapping, serialized components on things can sometimes be a challenge, but something that's done pretty frequently. Legacy systems are definitely a big one that we see across our customer base. Lots of legacy systems and ways of doing things within aerospace. It varies by customer and company. But we often find that leveraging and integrating data that exists is a challenge in some of the older systems. So as you're moving forward, as you're planning your traceability strategy and how to start to integrate these newer systems, focusing on that integration portion is very important to understand what the change management is going to be, how difficult it's going to be, and what you can get out of it. And definitely if it's paper-based, which honestly, there's a lot of that out there still, it's just exercise in manual labor to get any of that information into any kind of system, even if it's an Excel spreadsheet. So those are sort of at a high level some of the main challenges. Best practices, on kind of the flip side of the coin. Good identification, labeling systems, use of unique identifiers and barcodes and RFID. The less that you put in the hands of the operator or record on paper for them to have to transact, the better. But if they do need to, there are ways to simplify it through visual management tools and scanning, RFID, etc. There are even now like digital tags out there that we have a customer who's transmitting, orders and operations into those digital tags to get information. So they're kind of the sky's the limit there, but the idea is track it effectively, efficiently, and reduce the work needed to do so. Documentation and records, there's so many that occur as a part is being produced. I have seen production packages that are 2 to 3 inches thick by the time they're done. A tremendous amount of paper and data and recording that's necessary, but not usable. So being able to capture that information inside of systems electronically, whether you're making it or you're purchasing it, it is fundamental and definitely going to give you a lot of bang for your buck. Getting all that information out, like we talked about, into a visual representation of the relationships, what went into what did we issue through stores, even kitting, if any of your operations have that. You also want to know who's picking it, which ones are they picking the right ones, and tracking that sort of serialization through the whole process, even outside of the realm of manufacturing into warehousing and picking. Supplier management and quality control. So as the supply chain has expanded, it's gotten global. Some customers of ours have, very big parts that they make that they buy parts from 6, 7, 8 different countries. Again, it's definitely key to look at how you can integrate into their systems, understand where your parts are at, get early notification on what's happening with them, and also understand, like, are they managing their processes? Because more and more with your AS requirements and other requirements that are key to aerospace suppliers, they expect the same level of stringent discipline that you guys are displaying within your supply chain, right? And some are better than others, but definitely using these tools to digitize that information and simplify it and use the results and to prove that your quality auditors or your suppliers are doing their quality audits and obeying the processes is a huge advantage. To do that right without the digital tools is a lot of manual work and visits and audits. It's a challenge. Advanced technologies. So I think Boeing, Lockheed, several other larger companies, OEMs mostly, some smaller ones, but mostly OEMs are starting to implement blockchain for traceability. So I think last time I checked, Boeing had over $1 billion in their supply chain. That was a couple of years ago, probably fully within their blockchain platform. So use is expanding, new technologies are getting put out there, and it's all about the integrations and pulling the data in, and then storing it in a way that gives you that rock solid traceability record that you need. And then, like I mentioned a couple of times, continuous improvement and using this information not only to look backwards at what happened and why did that happen, but to aggregate it, analyze it, and look forward is a huge advantage of getting all of your activities within the system. It really kind of gives traceability a way to look into the future and make improvements that it just doesn't have when you're tracking individual sheets and individual operations, and you only look at them if there's a problem. It also, continuous improvement within the compliance standards. So as the regulations change, your systems can change and evolve with it. So they can be adaptable to new regulations and requirements and automatically update audits and things like that. So lots of solutions out there, but definitely with the requirements, with the footprint, with the complexity within aerospace, digitizing all of that and being able to report on it and use it is by far the goal, I think, with traceability, in my opinion. So in conclusion, helps you with your regulatory compliance, can ensure that you're following the safety requirements of your customers, because a lot of the buy-offs that they do are safety related, as well as improving quality to your customers and internally. The key elements we've talked about with making sure that the unique items are tracked, that documentation is tracked, that traceability and matrices and reports are there to easily report on and use the information. And then aerospace it's big, it's complex, and it's legacy. And it's not just legacy in the system mindset, but sometimes legacy in the way that business is done and the way that people want to operate within the supply chain. So there's definitely challenges there that we see within our customers. And then labeling, electronic data management, integrations, and real-time tracking, also like knowing what's happening now and being able to react if something falls outside of spec. If you're measuring and someone inputs an inspection, it's nice to be able to react now instead of someone turning in a checklist at the end of the day, and then maybe it gets entered, maybe someone sees it, maybe it's a day or two, and then you have to track it down and try and recover. So, getting that reaction plan with the real-time tracking prevents the need to have to look backwards and do the tracing. You still have it, but you've fixed it and you've addressed it, and you know how you fixed it and who approved it. So big advantages there, good best practices. And that's the end of my conclusions. Do we have any questions?
Yeah, thank you, Matt. So yes, let's open things up for questions. To our participants, you can raise your hand and we can unmute you. Otherwise, pop questions into the chat and we will address those. So Matt, it looks like we have one question in the chat. That being, what are the biggest change management issues that we see at our customers when implementing digital traceability from legacy paper systems?
Okay, so What I see as one of the biggest challenges is an underestimation of the change management required on the business side. On paper, like if you're looking at digital traceability, you're like, okay, well, it's an IT project. We need computers, we need scanners, we need all of this technology and software to be able to do it, which is true if you're going to do it and you're going to do it right. But the big part that's underestimated is how much the business operations need to adjust. You're effectively touching most people's daily jobs. They're doing things differently. Their processes have changed. They might be scanning where they were typing, or maybe recording information they've never recorded before in places that they've never recorded anything. So there's a lot that needs to be managed to not have a bumpy launch. And also you want to step into it. You don't want it to go from paper to digital like tomorrow. We're going to pull it like a switch. You want to find ways to implement it at a pace that's going to make progress, but is bite-sized, manageable. You're not overwhelming too many people with too many changes, but you're still getting the business value out of it. So it's sort of that changes by business, but I would say that's my biggest observation.
Very good. And it looks like there are no further questions in the chat. So once again, I want to thank everyone for attending today's Lunch and Learn session. Don't forget that this is the second of a three-part series dedicated to aerospace manufacturing. Our next and final Lunch and Learn session will be on October 8th. So please be on the lookout for an email invitation to that event in your inbox. Also, if you'd like to learn more about CAI software and our ShopView MES, please reach out to us directly by emailing info@caisoft.com or visiting our website, caisoft.com. Thanks again, everyone. Hope you have a great day.